Okay, here's part 2. Again, I have all the key formulas that you should have memorized, or need to memorize, for arithmetic, for geometric. Okay, now for problems 17, 18, 19, and 20, it says find part A, for part A I should say, find the sum of the first n terms of the series. That means I'm using this formula here, because as it turns out, these series are all geometric. Okay, and we're going to check to make sure they're geometric, but these series are all geometric. Then for part B, we're going to find out how many terms we would have to add up, the first n terms, to get a total or a sum of 341. So we're going to kind of dance about it and solve for n. So first things first, I see that I have a geometric ratio. Now I don't have to do a lot of deep analysis to determine that this is geometric. 4 times 1 is 4. 4 times 4 is 16. 4 times 16 is 64. This one is pretty obvious that my ratio is 4. Now again, I know that this is not a sequence with commas, but if you take the first two terms of the series, remember sequences are a list of terms, series are where you add the terms in the list. Okay? So in this case, I'm going to add the first 14. Now I only have 4 of them listed here, but I'm going to add the first 14. The good news is, unlike the arithmetic series where you have to know the nth term, or in this case the 14th term, I don't have to do that. I don't have to use this to find the 14th term. I could, but I don't need it. Notice that the formula, I only need the first term and I need the common ratio. So, I have the first term is 1. The sum of the first 14 terms is 1 times the quantity, 1 minus, I said that my ratio was 4, and that's going to be raised to the 14th power, so definitely you want a calculator somewhere close by, and this is all over 1 minus r, so 1 minus 4. Well, I remembered my calculator today, which is good news for me. Even though you can check your answers with the key, I'm going to go ahead and I'm going to take 1 minus 4 raised to the 14th power. Okay, and I get a really nasty looking number right there. Do you see it? And then I'm going to multiply it times 1, which doesn't change it. And then remember, I have to divide by the denominator, which is a negative 3. So I'm now going to divide by negative 3, and I get this number right here. Pretty healthy sized number. Hopefully that matches the key. I think I have the key. I probably should check this since I haven't worked these problems before to make sure I'm not doing something all incorrect or something like that. So let me check here real quick with my author's key. Maybe I didn't bring the key with me. Doesn't look like I did. Oh no, I did. So this is problem number 17. Yep. 89,478,485. Nice. Okay, now I need to, well, I'm not going to add up 14 terms if my sum is only 341 here. So now I'm going to try to figure out what n has to be to total up to 341. Now I wrote such a big number here, and I'm always telling you to write small, so I'm going to write it again over here so that I can have some of my space back. There we go. So for this is part A. For part B, I'm going to take s sub n, which is the first term, 1, times 1 minus r, which is 4, but I'm going to leave it as to the nth power because I don't know what n is, but it's got to add up to 341, so I set it equal to 341. So this is, now 1 times that, of course, is just 1 minus 4 to the n, all over negative 3 equals 341. I'm going to multiply both sides by negative 3. So that these cancel, and I get 1 minus 4 to the n is equal to negative 341 times negative 3. That's negative, that's a 3, that's a 2, that's 1,023. Now I'm going to subtract 1 from both sides, and I get the opposite of 4 to the n is equal to negative 1,024. Now that's an opposite, that's like a negative 1 times that. This is not negative 4 to the n, this is the opposite of 4 to the n. So I'm going to take the opposite of both sides, or multiply both sides by negative 1. And then I have to say, okay, and I get Mr. Calculator going here. 4 times 4, there's 2. That's 16 times 4, that's 3. Times 4, that's 4. 256 times 4, that's the fifth one. And notice what I get on the fifth time I multiply it. I get 1024. So n is equal to 5. Because you're going to have to take 4 to the fifth power to get this. And there's the second part. Definitely need a calculator. Next guy up. This one is also pretty obvious that it's geometric, and again, just about like this one, I don't have to do a great deal of work to figure out that 9 times 1 is 9, 9 times 9 is 81, 9 times 81 is 729. My ratio is 9. Just like back here, my ratio was 4. So I'm going to find the sum of the first 10 terms. Now, granted, you could get a calculator and punch out, because 10 isn't that many, and you could figure them out, but this is a lot faster if you just use this guy right here. There's my first term. Now it's 1 again. It doesn't always have to be a 1. It just so happened the first two are. Over there you can see those two are not. So a sub 1 is 1. I'm going to write s sub 10, because I'm adding up the first 10, is equal to the first term, 1, times 1 minus my ratio, which is 9, to the nth power. What? To the nth power? To the 10th power, because this is being raised, n is 10, all over 1 minus 9. So 1 times that's just 1, just that. So 1 minus 9 to the 10, and that's all over negative 8. So here we go again. Get my calculator out. 1 minus 9 raised to the 10th power equals, look at the size of this guy. All right? And now that's got to be divided by negative 8. Look at this guy. Hopefully that matches the answer. Did I leave the answers out? Of course not. If I had, I would be able to see if they matched up. And it matched up. That's your guy. So for this guy here, I'm going to bring the equal sign over because there's so many digits. 435848050. Put your commas in. 435,848,050. Whew. Now I'm not adding up the first 10 here to get that. You know what? Look at that. That's just over 800. And that guy's 729. I'll bet you a quarter, if you add just these four numbers, you get 820. I bet you a quarter that this answer is 4. Now I haven't looked at the answer to see, but I'll bet you it's 4. But I'm going to go through the same steps because sometimes it's not that easy and you need to see the practice. So this is the first term, 1 minus my ratio to the n, all over 1 minus my ratio. And this has to equal 820. Now this guy is negative 8 here. So I'm going to multiply both sides by negative 8. And I get, and I don't need the 1 there because 1 times that. I get 1 minus 9 to the n is equal to negative 0, 6 carry 1, 6560 there. Negative 6,560. Subtract 1 from both sides. I get negative 9 to the n, or the opposite of 9 to the n, is equal to negative 6561. I'm going to take the opposite of both sides, so I get 9 to the n is equal to 6561. And then I'm going to say, okay, 9 times 9, 81. That's 2 times 9, 729. That's 3 times 9 is 651. Well, your first video has now been rendered, and I just heard the sound. So that's good. So this is going to, n is going to be 4 times, because I took 4 factors of n. And there we go, and that's the second part of the answer right there. There's the first part for part A. Here's part B. For part A, for part B right there. These problems are the same exact kind of problem, except they gave you alternating series, which means that the signs alternate back and forth from positive to negative, from negative to positive. But you're going to work it the same way. It's just that it's just a little different, and your ratio is negative. In fact, if I look up here, I can see that if I multiply this by negative 3, I get this. If I multiply this by negative 3, I get this. If I multiply this by negative 3, I get this, and so on. I already know that my ratio is negative 3. Now, if you don't see that, take the first two terms. R equals negative 21 over 7. Yep, there it is, negative 3. So back to this formula, S sub 18 is equal to, you take the first term, which this time is 7, 1 minus my ratio, which is negative 3, to the 18th power, yikes, that's going to be a good size number, all over 1 minus a negative 3. Be careful with your signs here. 1 minus a negative 3, that's like 1 plus 3. So that's 7 times 1 minus, now negative 3 to the 18th power is going to be a peach. This is going to be positive 387,420,489. And that's all over 4. So I'm just going to let my calculator do this. Now be careful here. Don't let this think that, oh, you're subtracting a negative. That's the same as adding a positive. It turned out that this was going to be subtracting this number, which turns out to be positive because you have a negative number to an even power. But be careful. Leave that as subtraction. Just do the arithmetic here like I did. Now, if this had turned out to be a negative number, then you're subtracting a negative. Then you can change it to adding the opposite. So now I'm just going to go ahead and do all the rest of the arithmetic, and I get negative, because that's a big old negative number, times 7 is negative, divided by 4 is negative, I get negative 677985854. Let's check the answer key. I am clicking on all cylinders, so this is correct. Here, I'm going to write it again so that I can erase a little bit of this because I took up too much space. Right here. There we go. So there's part A. Now part B, I may have to erase a little bit of this as well. I am going to use this formula only. I'm solving for n. So I'm going to have 7 times the quantity 1 minus, remember my ratio was negative 3 to the nth power, all over 1 minus a negative 3, and I'm going to set it equal to 3,829. Again, I don't think this is going to be a very big number, because look what happens when I get to 18, so it's going to be a lot less than 18. And it's positive, so probably the last number I add is a positive. That's how it turns out. So this is 7 times the quantity 1 minus a negative 3 to the n, all over 4, positive 4 there, equals 3829. I'm definitely going to have to erase some here, because I'm running into this guy. So I'm going to multiply both sides by 4, and these cancel, and I get 7 times the quantity 1 minus negative 3 to the n. Be very careful here. And then over on this one, this is going to be a 6, carry a 3, it's a 1, carry a 1, it's a 3, carry a 3, it's a 15. I'm going to divide both sides by 7. I'm trying to get the n. So I have 1 minus a negative 3 to the n is equal to 2, 1. Let's see. 2, 1, 61 is 8, 7. I'm going to subtract 1 from both. Wait a minute, I think I messed this up last time, because I did this problem once before. 1, 13, 7 goes, that's 61, so that's 56, that's an 8. Boy, if I could do arithmetic, I'd be just fine. I'm going to subtract 1 from both sides, and I have the opposite of negative 3 to the n is equal to 2187. I'm going to take the opposite of both sides. I get negative 3 to the n is equal to negative 2187. Now, what number times itself times itself? How many times do I have to multiply negative 3 before I get this? Now, you could actually do logarithms here, but that's a pain, and I'm just going to go ahead and start multiplying by 3. There's 3, there's 4, there's 5, there's 6, I think it's 7. There's 7, that's the guy. So n is going to be a positive 7. I knew it was going to be odd because a negative number to an odd power is negative. I just had to get there. So n is 7, and that's my answer for part B. I'm going to have to erase that because I'm kind of merging into the other stuff. This problem is almost identical to this problem in that you have alternating signs, so I know my ratio is negative, and you can kind of see that the numbers absolute value-wise are getting smaller from 90 to 30 to 10. So it's going to be a fraction, a negative fraction. So if you're not sure, that just looking at it you can get it, just take the first two and write the ratio. It'd be 30 over negative 90, which is negative 1/3. So there's my ratio. R equals negative 1/3. I'm going to erase that so I have some space. See if I can squeeze this in around everything else. So now, I'm trying to figure out how much of this is the sum of the first 16. So, S sub 16 is equal to the first term times the quantity 1 minus my ratio is negative 1/3, careful here, to the 16th power, all over 1 minus negative 1/3. Oh, look at all the fractions here. Yikes! So this is going to be a little tricky here. Not too bad, but a little tricky. So this is negative 90. 1 minus, now you have a negative number raised to an even power, so it's going to be positive. It's going to be 1/3 times 1/3 times 1/3 times 1/3, 16 times. So 1 to the 16th, 3 to the 16th. This is the same as 1 over 3 to the 16th, which I'm going to figure out in a minute. 1 minus a negative 1/3, it's like adding the opposite, so that's 4/3. Now I'm dividing by 4/3, so that's the same as if I multiply by 3/4, the reciprocal, times negative 90, times this mess, 1 minus 1 over, now 3 to the 16th is a beast. Yeah, it's a beast. This would be 43046,721. 43,046,721. Now I'm guessing by now you're not doing this. You're grabbing a calculator and just doing it that way. Because 1 minus that, it would be, you'd have to get a common denominator, which would be that, so you'd have 43,046,721 over 43,046,721 for 1, minus 1, it's going to give you, ready? And he's doing this without a net, people. 43,046,720 all over 43,446,721. Now it'd be nice if I could simplify this, and look at this. 4 goes into that because it ends with a 20. Okay, I yield. It's time probably to grab a calculator, but I'm going to go ahead and see what I can do. 4 goes in that once. 4 goes into this mess. 1, 0. Well, let me just do it on the calculator so I don't screw it up. I get 10761 680. Now, as it turns out, let's see, that's 7, 11, 17, 24, 27. This is divisible by 3. You can knock out a 3 here. 3 goes into that. 3 goes into 43. 46, 721. Holy smokes, this goes in 14348,907. I don't know if this is worth it. So now I have this times this all over this. Time to grab a calculator. Did they punch it out as a decimal on his answer? This is problem number 20. Yeah, he did. It turns out to be negative 67.5 according to him. And that kind of makes sense. I have a negative times a positive, and this is a little bit, this is about like 5/7, so that makes about sense. It's nice that it came out to a nice decimal that ended at tenths there, but that's what you would do. You'd have to be extra careful with this. Now, on top of all that, I've got to still go through this route and take negative 90, 1 minus negative 1/3 to the end, all over. Now remember, this turned out to be adding out, this is 4/3, and I got to add it, and it's got to be equal to negative 200 over 3. All right, this is the same as times 3/4. I'm going to have to definitely erase right in here. So this is 3/4 times negative 90 times 1 minus negative 1/3 to the end equals negative 200 over 3. Now this is number right here. I can do something here. 2 goes in that twice, 2 goes in that 45, so that's negative 135 over 2 times 1 minus negative 1/3 to the n equals negative 200 over 3. Yikes. I'm going to multiply both sides by the reciprocal of this. Alright, so these cancel out. That gives me 1 minus negative 1/3 to the n is equal to this mess. Negative times negative is positive. It looks like 400 numerators all over 405. Well, that turns out to be, let's see, 5 goes into that. This is 80 over 81. I'll subtract 1 from both sides. So I get the opposite of negative 1/3 to the n is equal to, now 80 81st minus 1 is like 81 81st, so that's going to be negative 1 81st. I take the opposite of both sides, negative 1/3 to the n is positive 1 over 81. Now, negative 1/3 times negative 1/3 times negative 1/3, how many times? Well, if you raise it because it's positive, you know it's even. It's not a 2 because that'd be 1/9. It turns out that this is 4. And that's your answer for part B. N equals 4. That one's a beast compared to the others. Alright, now, this is asking you to find the sum of each series, which is kind of nice because you can find the first term right away, and you can find how many terms you're adding by looking at your limits of summation here. Like for here, it goes from 1 to 10, so n is 10. A sub 1, this is your general formula right here. What happens when you plug 1 in? That's your very first one, right? You plug 1 in, you're going to get 6 times 2 to the 1 minus 1. That's 0. 2 to the 0 is 1, so this is just 6. There's my n, there's my a sub 1. So I'm going to add up the first 10. So it's, what did I just say? It was 6 times 1 minus, okay, what's my ratio? My ratio here is going to be 2 because that's the factor that's being multiplied, that's being raised to the power. So my ratio here is 2. So this is 2 to the 10th. And that's all over 1 minus 2. So this is 6. 1 minus 2 to the 10th is 1,024. And that's all over negative 1. 1 minus 2. So this is 6 times negative 1,023 all over negative 1. Of course, negative over negative is positive. So I just have to multiply this. So that's an 8, carry a 1. 3, carry a 1. 1, and a 6. 63, or 6138. 6,138. Let's hope that I matched the gentleman's answer. I did. Once in a while. Next guy up. Again, notice that your bottom index here, your lower limit of summation is a 1. That's great because now you know from 1 to 8 that n is 8. You also know that when you plug 1 in, you can find a sub 1. A sub 1 would be 5 times 4 to the 1 minus 1. Can't beat that with a stick. This again is 0, so 4 to the 0 is 1, and then times 5 is 5. My ratio is 4 because that's the base of the exponent. So now, now I'm going to do that each time that my bottom limit is 1, but you'll notice here that my bottom limit is 0. I'm going to do that one a little differently. I'm going to show you that in a second. But S sub 8 would be a sub 1, which is 5 times 1 minus my ratio 4 to the 8th power, all over 1 minus 4. Now I can't do that one in my head. Sorry to say. 4 to the 8th. Well, maybe I could. Yeah, this is going to be 5 times the quantity 1 minus 65,536 all over negative 3. 5 times this would be negative 65,535 if I subtract 1 because I have a positive and a negative, all over negative 3. Well, negative over negative is positive. Now 3 probably goes into there, but I'm going to multiply it out the long way here. 5 times 65,535 divided by 3, and I get 109,225, and hopefully that matches the answer. And it does. Okay, so one to go. This one's a little different because you're not starting with a 1. Plug the 0 in. I'm just going to actually expand this. Plug the 0 in. 0 plugged into there, that would give me negative 1/2 to the 0, which is 1, so my first term is 12. Plug 1 in, because you're going to go from 0 to 9, then you go to 1. Negative 1/2 to the first is negative 1/2 times 6 times 12 is negative 6. And it's my common ratio here is negative 1/2, so it's like I'm multiplying by negative 1/2 each time, and so on. And I have how many terms? Well, I'm starting with 0 and I'm ending at 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, there's 10 terms. So n is 10. Remember, since you're starting at 0, it's just one more than the upper limit of summation. This is a 9, so one more than that, that'd be 10. My common ratio is that. I need my first term, there it is. I'm ready to roll. S sub 10 is equal to 12 times the quantity 1 minus, that's a negative 1/2, love those negative fractions, raised to the 10th power, all over 1 minus negative 1/2. So 1 minus negative 1/2, that's the same as 1 plus positive 1/2, that's 3 halves. My bottom there, 3 halves. Now this is negative 1/2 times negative 1/2. It's raised to an even power, it's going to be positive. This is going to be 1 minus 1 over 1024. So this is going to be 12 times 1, hang on a second. Common denominator would be 1024, so 1024 over 1024 minus 1 over 1024, 1023 over 1024. Divided by 3 halves is the same as times the reciprocal 2/3. And again, you could get Mr. Calculator out here. 2 goes into that 512 times, 3 goes into that 4 times, so it's 4 times the top. That's 4,092 all over 512. Crud. I can divide top and bottom by, I think, by 4. 4 goes into that, 64. 4 goes into that, 1023. So I get 1,023 all over 64. At least I hope I did. The answer is probably a decimal. Let's see, this is problem number 23. No, he left it as 1,023 over, see, I divided, oh, crud. He's right and I'm wrong. It's 128. 128, sorry about that. There's your answer. Did too much in my head and I screwed up. Okay, now there are 4 problems left. And rather than create a whole new video, I'm going to try to rattle through some of these. I'm just going to erase some of the work that I already have put up here, so I have some space. I know that these videos are long and boring, but at least this way you have something that you can refer to. You can always fast forward. And so it says that the U.S. Open tournament, U.S. Open tennis tournament is held annually at Flushing Meadow in New York City. In the first round tournament, 64 matches were played. In each successive round, the number of matches played decreases by 1. Find a formula for the number of matches played in the nth round. So you have, and this is problem 24, so you're starting with 64, then the winners play, so there's 32 winners, and then there's 16 winners, and then there's 8 winners, and then 4, and then 2, and then there's the champion, that's 1. So in this case it says, find a formula for the number of matches played in the nth round. Well, this is geometric, my ratio is 1/2. This is my first term. Go to this guy. A sub n is equal to 64 times 1/2 to the n minus 1. So this is the part here. It says, for what value of n does your rule make sense? Well, it doesn't make sense if you go beyond 1, 2, 3, 4, 5, 6, 7. So it would be for n between 1 and 7, and n is an integer, is a whole number, we'll say. Because you can't put a negative in, right? You're not going to have a negative number of terms, so n's a whole number, and it would have to be between 1 and 7. If it was more than 7, the next one would be a half, and you can't have half of a person there. No weird answers, please. So anyway, that would be the second part of problem 24. Problem 25, find the total number of matches that were played. Well, you just add these. So for problem 25, you're going to add 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. So what we can do is we can either add them with our calculator, or we can go to here. this 1, 2, 3, 4, 5, 6, 7, s sub 7 would be the first term, 1 minus a half to the 7th power, all over 1 minus a half. So this is 64. This is 1 minus 1 over, let's see, 7 would be 128, all over a half, or multiply by 2. So that's 2 times 64 times, now this would be 128 over 128. So this would be 128 over 128 minus 1 over 128, 127 over 128. Look at this. This is 128 over 1 times 127 over 128. 127. It might have been faster just to add up the numbers on your calculator. So there's problem number 24. So let's, or 24 and 25. So let's look at the last problem or two. I haven't read it yet, so hopefully I won't get stuck on this, because sometimes his last problems are pretty challenging, and I haven't done this in a while. When a computer must find an item in an ordered list of data, this is problem 26, such as an alphabetical list of names, it may be programmed to perform a binary search. The searching technique involved jumping to the middle of the list and deciding where the item is. If not there, the item decides where the item comes before or after. Half of the list is then ignored on the next pass through the list, and the computer jumps to the middle of the remaining list. This is repeated until the item is found. Okay, an ordered list contains 1,024 entries. Find a rule. Okay, so what you're doing here is you're starting with 1,024. If you jump to the middle, then you're at 512, because there's 512 to the left, 512 to the right. If you jump to the middle again, you take half of that, that's 256. Then 128, then 64, then 32, then 16, then 8, then 4, then 2, until you find the one item that you're looking for. So that's the sequence, the geometric sequence that they're describing here. You're to find a rule for the number of terms after the nth pass through the list. So back to this guy, a sub n is the first term, which is 1,024. My common ratio here is a half, because I'm multiplying by a half each time. So it would be 1/2 to the n minus 1, and that would be the answer there for problem 26. For problem 27, it says, in the worst case, the item to be found is the only one left on the list after n passes through the list. What is the worst case value of n for a binary search with 1,024 items? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It should be, 27 should be that there be 11 searches. Let's see what he's got. No, he's got 10 passes because he doesn't count this one, because this one is the final answer. So he counts only the first 10. So let's see what happens here. If I was to set 1,024, 1/2 to the n minus 1 equal to 1. See, I divide both sides by 1,024. And I'm just kind of messing with this one now. This is the same. Now let's see, I'm going to get 11 again. This is the same as 1 over 2 to the 10th, which is 1/2 to the 10th. So if these bases are the same, then these are equal. So n minus 1 equals 10. So n is equal to 11. I guess he wants me to stop here. We're starting with this. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. I counted the first one. It's 10 the whole time. Sorry about that. I counted the first jump, so it's 10 passes. There's your answer. All right, that was a really long video. Give me a call and ask me questions if you're not sure. I'll be happy to help you.